In this video, we'll explore map, filter, and reduce. These tools are essential for writing code that's easier to understand and maintain. Imagine you're working on an RPG game, and you've got an object that contains the inventory of a character, and you've got another variable that contains an array of item IDs that are currently equipped. How would you go about getting the names of the equipped items? Let's start by doing this with a plain loop. To get the names of the equipped items, we can use a loop to iterate through the inventory. For each item in the inventory, we can use another loop to check if the item ID matches any of the equipped IDs. And if it does, we can add the item's name to the equipped items array. Let's log that to the console. And sure enough, it works. But as you can see, this process can be quite tedious and time-consuming. This is an example of imperative programming, where we specify explicit steps for the computer to follow in order to achieve a desired result. Let's start again. The goal is to extract the names of the equipped items from the inventory and store them in equipped item names array. We can use filter method to iterate over each item in the array and pass it as an argument to the callback function. If the function returns true, the item will be added to the new array. Otherwise, it'll be filtered out. At this point, equipped item names is an array of objects, but we need only the names. And that's where map comes in. Because filter returns a new array, we can use method chaining to call map on the filtered array directly. And the idea is the same as with filtering. The map also takes in a callback function as an argument, and it's going to transform each item in the array by returning the name of the item. Now, let's log equipped item names to the console once more. And as you can see, using array methods like filter and map allows us to achieve the exact same result as before, but in a more concise and readable way. Here is another example. Let's calculate the total damage of a character wielding two weapons. We'll start by using a similar approach as before to understand the basic process. First, we'll create a variable to keep track of the total damage, and we'll iterate over equipped items array to retrieve the equipped weapon ID. We'll need another nested loop to search for the weapon in the inventory, and if the weapon is found, add the damage to the total damage value. Let's log the total damage value to the console to see the result. Now that we have a sense of the process involved, let's try to simplify this again. We'll start by using the filter method to narrow down the inventory array to only the equipped items, and then use map to get the damage value of each equipped weapon. And finally, we'll use the reduce method to sum up all the damage values of the equipped weapons and get the total damage. The reduce method takes in a callback function and the initial value as arguments, and the callback function is called for each item in the array, and it takes in two arguments as well, the accumulator and the current array item. The reduce method can be a bit difficult to understand at first, so let's dive in a little deeper. It starts with the initial value of 0, and in the first loop iteration, this value is going to be passed to the accumulator argument of the callback function. If we imagine that the item value is 30, the result of this expression is going to be 30, and it's going to be returned and stored as the accumulator. In the next iteration, the accumulator value has now been updated to 30. And the next item value is 58. So the result of this expression is 88. Since there are no more items in the array, the reduce is done and the final value of the accumulator is returned. Log that to the console and see if it works, and looks like everything is working as expected. Once you get the hang of it, it can help you write more concise and readable code. This is where the power of declarative coding becomes evident. Rather than writing code that describes every step of the process, such as loops and conditional statements, you write code that clearly describes what's going on. And that's all for now on writing code. I'll see you in the next episode.